Point two is scientific notations. I'm sure a lot of you guys already know what scientific notation is, but here's going to be a quick review and how to use scientific notation and when to use them. So there is a condition for a number to be a scientific notation. So a lot of you guys know that it is a times 10 to the nth power. But the condition is this a right here has to be between 1 and 10. If it is anything bigger than 10 or anything smaller than 1, then it is not a scientific notation, even though it's in this form. So remember, it can't be 10 or above, or it can't be below 1. And n is an integer. That means positive and negative whole numbers. And that's going to be our exponent. So some of the questions that we're going to be dealing with today is to whether if this is a scientific notation or not. So looking at 1a, if you notice, it's 0.46 times 10 to the fourth. And you got to look at this a right here, and that a is below 1, so this is not a scientific notation. So you would say no, and 0.46 is less than 1, so it can't be a scientific notation. So looking at B, this one 3.25 times 10 to the negative second, 3.25 is between 1 and 10, so this is a yes, it is a scientific notation. And you could explain it by saying it is between 1 and 10. And then the last one right here, 13.2 times 10 to the 6 is no, because 13.2 is bigger than 10, and it can't be bigger than 10. It has to be less than 10. Okay? Now, the reason why we use scientific notation is when we have a very big number or very small number. We don't want to write all those zeros, so we write it in scientific notation form. So one of the things that I talk about is that when you have a big number like 234 million, big number tells me that I'm going to have a positive, my n will be a positive exponent, positive integer. So we're going to make this big number become between 1 and 10. So remember, there's the decimal. If you don't see it, it's always at the end of the number. And we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8 until we make the number between 1 and 10. So 2.34. And we move it 8 times. And because this is a big number, we keep it as 10 to the 8th power. We keep that exponent be positive. Now, if you notice, this is a very small number, 0.00063. So small numbers will tell us that the n has to be negative integer. So same thing, we're going to move the decimal until we make the number between 1 and 10. So in this case, we're going to move it over 1, 2, 3, 4, 5, and we'll make it 6.3, and 6.3 is between 1 and 10. And since we moved it to 5 spaces, this is going to become negative 5. So 10 to the negative 5th power is the scientific notation form of that small number. Okay, so from standard to scientific notation form, if you're moving the decimal to the left, the exponent then the exponent gets bigger by that number, and then if you're moving it to the right, the exponent gets smaller by that number. So just remember this: if it's a big number and you're rewriting as in scientific notation form, you got positive exponents, and if it's a very small number, you're gonna end up with negative exponents. And you could pause and do a quick check here in this problem, okay? And then you could talk about whether it is a scientific notation or not and explain why. Second part of this is we're going to talk about how to put numbers in order. A lot of times when scientific notation, when it's in that order, it's easy to put them in order because you could tell by the exponents. So in this case, I have 10 to the 5th, I got 10 to the 4th, and I got 10 to the 3rd. But if you notice, this is not in scientific notation because this number is not between 1 and 10. So you're going to make it. So we're going to make this become 1, 2, 3. So this means 6.3 times 10 to the negative third times 10 to the fifth. And then we're going to add those exponents together. So 6.3 times 10 to the second power. So that's this one. This one is 6.03 times to the 10 to the fourth. This one I got to make it into scientific notation. So we're going to move it over 1, 2, 3. So that becomes 6.103 times 10 to the, this is a big number, so the third power. And we're going to do this again. This is not a scientific notation, but so we're going to make it smaller. So this becomes 6.31 times 10 to the 1 first power, so we're going to make it times 10 to the third, so this becomes 6.31 times 10 to the fourth power. So now I want to put it from least to greatest. So my smallest exponent, which is this one, so it would be 6.3 times 10 to the second. Next one will be 6.103 times 10 to the third, and then the next one is, this is smaller, they have the same exponent, so this smaller than this one, so it will be 6.03 times 10 to the fourth, and then the last big number would be 6.31 times 10 to the fourth power. And that's how you use scientific notation to put numbers from least to greatest. Another type of question you will see is to multiply. So we're going to simplify, and we're going to answer our simplified form in scientific notation. So do not distribute. You only distribute when there's a plus sign in here. This is multiplying. So what we do is we just multiply those two together. 6 times 8 is 48 times 10 to the negative fourth power. 48 is bigger than 10, so what we're going to do is we're going to make it between 1 and 10, so we got to move the decimal over 1, so this becomes 4.8. And whenever you go from bigger to small, we're going to add an exponent, so that becomes 10 to the negative third power. Let's multiply these two together. 0.3 times 1.3, so 3 times 3 is 9, 3 times 1 is 3, and there are 1, 2 decimal spaces, so 1, 2, so that's that, times 10 to the third. Now 0.39 is a small number, so we're going to make it between, it's less than 1, so we're going to make it between 1 and 10. So we move it over 1, 3.9, so then that means I'm going to subtract 1 because this was a smaller number, times 10 to the second power. So this would be how you multiply in scientific notation and make it in scientific notation form. Okay, so here's another quick check where you can multiply and rewrite your answer in scientific notation form. So remember, scientific notation is in the form of a times 10 to the nth power, where n is an integer and a has to be between 1 and 10, but it can equal 1.